because you in the video you made, you're using this one where we press the buttons and it makes a beep. Yeah. So okay, if we open the buzzer node, we'll see what's inside the buzzer node. And as usual, in any node in XOD, you have some input ports, some output ports, and then there's a part which is, in this case, in some other cases, called not implemented in XOD, which means it's essentially C++ code that would run in Arduino wrapped into a special container for XOD to then inject his own code in there before it gets compiled and uploaded to the Arduino. So if I double click on this, it will open the code, and this is a typical wrap-up code that XOD produces. It always starts something like declaring a state for this node. So in XOD, each node has a state, which could be active or non-active or whatever. And then there's a placeholder, which is this one, which is this generated code amongst double curly brackets, which is where XOD will introduce his own code, the code that is at least a part of the XOD runtime that is used to actually run the rest. So when this code gets compiled, when we try to upload to Arduino, XOD will use this framework somehow, add his own code here, and then compile and upload. And the function itself, the C++ code which is run into this node, in this case is the buzzer, it works like that. You have a function which gets evaluated somehow, and what you can do in this function is use this state which you somehow declared just before, or if you can also declare other structures that you can use, but this is the one you need to use in XOD at least. And this is actually you have a variable called state, which is a pointer to a structure in this case, and you get the state. This is a XOD native function which will be implemented in this part here. So you get the state of the node, and then you can use the state variable to decide what to do. Then in this case you also read the ports. If you remember before, there was if I go back here and I open this one, actually if I go back, sorry, there are these entries, these ports. And so if I go to the code again, you'll see there are port frequency enable, which are variables that get the values out of the input ports. In this case, each port has a name. In this case there were port frequency and N for enable, and in the code they are referred as input underscore name of the port. If I go back, you'll see that the ports are called port in for enable and frec. So, and in the code they get referred as in this way: input underscore port, input underscore frec, input underscore end. And that's the syntax you get. You use a get value and you will get this internal variable. You assign it to a variable that you use in the code, which is called, in this case, port frequency enable, and you give the type is auto in this case. And then you actually do what you want to do. In this case, what happens is that you just use one of the predefined function in Arduino, which is the tone function. So tone function in Arduino just produces a buzz tone, a square wave on a certain pin with a certain frequency. So what happens, what you do is, if the state is enabled, so if the buzzer has been enabled, so it means that enable pin or input is up, so it's true. Then you decide on which port you want to write the sound, or you want to output the sound, which is the port, defining the port variable or the port input for the node. And you say, so this pin is made as an output, and then you produce a tone, and again this is Arduino code, on that pin. If it's not enabled, you should turn off the tone on that port. This is important because otherwise we'll go on making tone and you cannot change frequency. Every time you want to write a new tone on a port, when you want to make a new sound, you have to use this, you have to shut down with no tone. And then and then there's a little bit of control to check if it was on before. You have to be sure that it doesn't get hung up somehow. So if the tone was on, the buzzer was on, and was producing a sound, then when you finish, because now is not enabled. So if it was a transition from enable to disable, then you emit a pulse on the output, which is the output port. So you emit a pulse saying, well, I'm done with the tone. This is emit value. And then you reset the pin mode from output to input, so that it stops completely the buzzer. So technically it puts the output into 3 state, so that it's high impedance, and it silences the buzzer. Both the active and the passive buzzers are stopped in this case. So both of this of the different kind of buzzers will be stopped in a sense. And then you say that you change the state from enable to disable, so not enable, and that's it. So essentially, if it was enabled, you can make the sound. If it was enabled and then you turn it off, it emits a pulse saying that I'm done, and it makes sure that the buzzer stops buzzing by putting the output into a 3 state, so high impedance condition. And that's essentially what the buzzer does. And this buzzer then we will use in all other buzzing things. So that's it.